Alright, everybody. Things are about to get really crazy in here. So, as the crusty black guy in Jurassic Park would say, with a cigarette hanging out of his mouth, hold on to your butts. Something like that. So, yes, we're talking about transformations of trigonometric functions. So this is where it gets really crazy, and we're just going to dive right in. Okay, so the basic formula we have for a transformed trigonometric function, a transformed sine function in particular, is y equals a sine omega, that's not a w, it's a little Greek letter, x minus phi, which is also a little Greek letter. Yeah, and that's it. So each of these things does different things to the equation. So we still have our sine and our x, but there's a bunch of other junk around it. So let's explain what that junk is. A stands for amplitude. And amplitude is the vertical stretching or compression. Okay. I just about said W. Omega. Omega. Omega is a very special letter. It's the horizontal compression or stretching. Okay. So this is different based on different functions, but it really only changes between tangent, cotangent, and everything else. Okay, so what on earth do I mean by that? To find how much we actually compress or stretch the graph, we use the period of whatever the original graph is. So sine, its period is 2 pi. Cosine's period is 2 pi. Cosecant, secant, their period is 2 pi. Tangent and cotangent, their periods are pi. Okay, but it's period divided by omega. So omega is not the exact amount that we need to stretch it or compress it horizontally, but it's the period divided by omega. Okay, and that may not make sense right away, but we'll explain it. Okay, and phi, finally. Phi, phi, fo, fum. That is the phase shift. Phase shift, which sounds really awesome. Phase shift. And that is movement. Move. Left or right. And the amount that it moves. And that is not just phi, but it is phi over omega. Okay, so we take phi and divide it by omega, whatever those are in any instance. Okay, notice that it's minus phi, so if you have a negative in your parentheses, that means phi is positive. Okay, so don't get confused about that. It's a lot to remember, so you might want to watch this about a gazillion times before you take your test. And then you'll be like, I'm a pro at this. I'm a math wizard. That's what everyone wants to be when they're a kid, when they grow up. Anyways, so let's do the period transformation graph thing of sine. So let's have an example. Y, and I specially formulated this one, equals negative 2 sine. Okay, already I've introduced something that I didn't have originally. Of pi over 2, so pi over 2 x minus... See, okay, I specially formulated it and then I forgot that I changed it. Y equals negative 2 sine 2x. How's that? That's better. Minus pi over 4. Okay. So, we have an amplitude of the absolute value of this, not just the negative, but it's the amplitude is 2. So that means instead of going up to the 1, it goes all the way up to the 2, and then down to the negative 2. Okay, this negative here, that means something else. That means that the graph is flipped upside down. It's gone, whoosh, you know, kind of like the Fresh Prince of Bel-Air's life. It got flipped, turned upside down. Okay, so next, what else do we need? We need to know the period. So the period, okay, the period of regular sine is 2 pi. So 2 pi divided by omega, and omega is 2, okay? So we have 2 pi over 2, and that is whoosh, pi. Great. Just wonderful. Okay, and the phase shift. Phase shifters. Phase shift is phi divided by 2. Okay, so we have pi over 4 divided by 2. Okay, let's do our old fraction dividing method. It's pi over 4 times 2 over 1. Sorry, whoa. Reverse. Yeah, 1 over 2 times 1 over 2. That means I did the graph that I did before this wrong. Isn't that wonderful? So now we have pi over 8. Okay, so our phase shift has gone pi over 8, and this is going to make everything really crazy, but that's great because we can work through this together. All right. So let's, wow, what was that? Whew, that was scary. Let's make our rectangular coordinate axis of x and y. Yes. Okay. We have a amplitude of 2. So let's just say this is 2 and this is -2. And look at that. It's actually 2 lines away. Isn't that wonderful? Okay. So usually sine starts at 0, 0. I beg your pardon. That was obnoxious. Regular starts at 0, 0, but we have a phase shift of pi over 8, so that means we have to move over to the right pi over 8 because it's positive pi over 8, okay? Positive pi over 8, so that means we'll have a point at pi over 8, 0, not 0, 0. Pi over 8, 0. Okay, now everything's going to get really crazy. We have a period of pi, okay? So we're going to have a 0 at pi away from pi over 8. So how do we determine pi? What's pi away from pi over 8? Well, we have to say pi over 8 plus pi. Okay. What is pi in terms of eighths? Well, it is, wow, my brain. It is 8 pi over 8. Okay? That makes sense. Okay, so now we have 9 pi over 8. Wow, things are going to get really ugly in here. Okay, so let's go over here. Boop. Call that 9 pi over 8, and we have a point, 9 pi over 8, and this is where it repeats again. Okay, so 9 pi over 8, 0. Okay, halfway in between these two will be another x-intercept. We know that from just what sine looks like. So halfway in between that should be pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8, 9 pi over 8. So that makes sense, yes. So actually, which way is it going to go? It's going to go like this. I want to have this in the right spot. What do we say? 5 pi over 8 and 0. Okay, now it's going to get really weird. I have a spot here and a spot here. What we could have done here to make that easier, and what we should have done in the first place, we know that the middle of the graph of sine, regular sine, is pi over 2. Sorry, it's pi. It's just regular pi. But the period is pi, so it'll be pi over 2 in the middle instead. Wow, isn't this confusing? It'll be pi over 2 in the middle, so pi over 2 plus pi over 8 is where we will have a point, okay? So pi over 2 plus pi over 8, so pi over 2 is 4 pi over 8, plus pi over 8 is 5 pi over 8, and that's how I got that, Okay. All right, so let's take the next points here. What will this be in terms of pi over 8? Well, we could say this is halfway between 5 pi over 8 and pi over 8. So that's 3 pi over 8, evidently. So let's just call that 3 pi over 8. We know it got flipped upside down because of the negative, and it's at 2. So we have here a point 3 pi over 8. Instead of going up, if it were positive, 3 pi over 8, negative 2. Okay? Okay, pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 7 pi over 8. So we will have 7 pi over 8 and 2. Okay. So it will go something like this. So we have a period of pi. We know that this pi over 8 is pi units away from 9 pi over 8, which makes sense because we did the math for that. So where will this point be? 7 pi over 8 minus pi. Let's say 7 pi over 8 minus pi, which is 8 pi over 8. And that will be negative pi over 8. So we'll know there will be a point over here at negative pi over 8. And I did the dimensions all wrong, so this is going to be very stretched. But it's going to go like this. So we have negative pi over 8 and 2. So y is 2 at pi away from 7 pi over 8. Make sense? If not, tough muffins. And if you're one of my students, go ahead and ask me for help. I'm willing to help at lunchtime or anything. All right, thanks for watching. Goodbye.